Okay students, welcome back to another video. In today's video, we'll continue with the paper 0625, paper 4, and it is October-November 2023, and we will continue from question number 7. So the question number 7 is saying that there is a plastic rod which is uncharged. When the rod is rubbed with woolen cloth, the rod becomes negatively charged. Explain in terms of particle why the rod becomes negatively charged. So suppose we have a plastic and a cloth and we rub it together. The cloth will loses its electron and it will become positively charged. Plastic will gain an electron and it will become negatively charged. So we can say that the plastic has become positively charged because plastic rod will gain electrons from woolen cloth and it will become negatively charged. Next part is saying that figure 7.1 shows a negatively charged sphere and there is electric field around it. Show what is meant by electric field. So there are charges, positive and negative, and there is this yellow region around it. If some charge is outside this region, there would be no force that will act on this charge. As soon as the charge enter this yellow region, it will experience a force, and the force can be attractive or repulsive depending upon the quality of the charge. If the charges are same, they will repel each other, and if the charges are different, they will attract each other. For example, if I place negative charge this side, this will feel a force of attraction. So we can say electric field is a region around charged body in which other charged body experience force. Second part says on figure 7.1, draw the patterns of electric field surrounded the sphere and indicate its direction. As it's a negative charge, so the electric field would be radially in. C part says figure 7.2 shows a small negative charge Z placed near a sphere. The charge Z experience a force due to electric field of S. This is a negative charge. On figure 7.2, draw the arrow to show the direction of force on Z. Z is negative charge, sphere is negative charge, negative repel each other. So this charge will feel a force of repulsion towards this direction. 8 question says a cylinder is made of modeling clay. The modeling clay is an electrical conductor. Figure 8.1 shows the cylinder. So here is a cylinder which has cross-sectional area of this side, and this is the length of the cylinder. The cylinder is connected into a circuit. Figure 8.2 shows that the circuit also includes a battery of electromotive force 9 volt and resistor P. So here is a battery of 9 volt, this is resistor P, and there is a cylinder attached to it. The resistance of P is 4 ohms and current in the circuit or P is 1.5 amperes. The first thing we need to know that this is a series combination. So the current would be same across every component. So if this component has the current of 1.5 ampere, this would also have the current of 1.5 ampere. The resistance of P is 4 ohms. Next thing is that total voltage in series circuit is equals to sum of voltage across each component. First part says we have to calculate the magnitude of charges that passes through P in 600 seconds. The charges that we need to find, the time is given, and the equation that connects charges and time is I equals to Q over T. Arranging it with respect to charges would be current times T. So current is 1.5 and the time is given by the question, it is 600. So the number of charges that travel in P in 600 seconds is 900 coulomb. Second part says that the resistance of the cylinder of the modeling clay. So we have to get the resistance of the cylinder. For this we can use Ohm's law, which says V equals to IR, and I arrange it with respect to R, it would be V over I. Okay, we know the current of this modeling clay, but we don't know the voltage of this clay. and we have to get the voltage of this clay. And to get the voltage, we can use this second equation, which is total voltage across series combination is equals to sum of voltage across each component. We know the total voltage is 9, and we can get the voltage across P by using the Ohm's law, which is V equals to IR. The current is 1.5 and the resistance is 4. So multiplying these together, the voltage would be 6 volt. So putting 9 equals to 6 volt plus voltage across the cylinder. So cylinder voltage would be 9 minus 6, which is 3 volt. So this cylinder has the voltage of 3 volt. Now we have the voltage, so we can get the resistance by dividing the voltage by current. I am writing this equation again over here. So resistance equals to voltage over current. Voltage of cylinder is 3 volts and the current across the cylinder is 1.5 amperes. So the resistance would be 2 ohms. The next part of the question says that the cylinder is removed from the circuit and it is replaced with a new cylinder made of the same modeling clay. The new cylinder is twice the length and has half the cross-sectional area of the first cylinder. Calculate the time that it now takes for the magnitude of X charges to flow through P. So we have to get the time for 900 coulombs of charges to pass through P. The equation would be Q over T. Arranging it with respect to T would be charges over current. The charges are 900 coulomb, but the current is no longer 1.5 amperes because of the fact that we have replaced our modeling clay, and this time the resistance of modeling clay is changed. And due to this change in resistance, the current of the circuit is also changed. We know that resistance is directly proportional to length. So if the length is doubled of the clay, the resistance of the clay would also be doubled. So if it was 2 ohms before, now it would be 4 ohms. And similarly, the cross-sectional area of the wire has been halved. We know that resistance is inversely proportional to cross-sectional area. So if the cross-sectional area reduces, the resistance increases. So if the cross-sectional area is halved, the resistance would be doubled. Before it is 4 ohms now, and after being doubled it would be 8 ohms. So by replacing this clay, we have changed the resistance from 2 ohms to 8 ohms. And now how will it affect our current? For example, now this clay has a resistance of 8 ohms and our P already have resistance of 4 ohms. So the total resistance of our circuit now is sum of these two together, which is 4 plus 8, and it will give us 12 ohms. So the total resistance of our circuit is now 12 ohms. And if we want to know the current of our circuit now, it is not 1.5 amperes. We have to get it by Ohm's law. I equals to V over R. Voltage of the circuit is the same, which is 9, and the resistance is now 12. So our current is 0.75 amperes this time. So I will plug in the new current of our circuit, which is 0.75 amperes, and now the time it will take for 900 charges to travel, 900 coulombs of charges to travel, would be 1200 seconds. I hope you get this question very well. Question number 9 says many household smoke alarms contain sample of radioactive isotope americium-241. Americium-241 is an isotope of element americium that has nucleon number of 241. Nucleon number is also known as mass number. State how the composite of nucleus of americium-241 differs from the nucleus of americium-242. So we have this americium-241 and americium-242. Whenever you write any atom on bottom left side, you write atomic number of an atom, which is basically number of protons, and upside you write mass number of an atom, and mass number is basically the number of protons plus number of neutrons of an atom. And the next thing you need to know is that whenever you have isotopes, these two are isotopes of each other. So isotopes are basically the atoms which have same number of protons, but they have different numbers of neutrons. So isotope is something with same number of proton but different number of neutrons. So they basically differ from one another because americium 242 has one more neutron. Part number 2 says an atom of different element has a nucleon number of 241. State two differences between the composition of nucleus of this atom and nucleus of americium 241. So this time we have another unknown atom with a nucleon number of 241, and we have to compare it with an atom of americium 241. So we know that these are not the isotopes, so they would have different number of protons and different number of neutrons as well. So I have written two differences, different proton number and different neutron number. B part says americium 241 decays to an isotope of neptunium by alpha particles emission. Complete the equation. So we know that this is emitting alpha particle which has two protons and 4 nucleon number. We have to balance the equation. 93 this side, 2 this side. We'll add them together. It would be 95 this side. So if there's 241 this side, 4 over the alpha particle, so there would be 237 over here, because 237 plus 4 will give you 241 and 93 plus 2 will give you 95. Second part says one reason for using an isotope that emits alpha particle in smoke detector is that alpha particles are more strongly ionizing than beta particles. Explain why alpha particles are more strongly ionizing than beta particles. Why alpha particles have more ionizing power? Because of the fact that alpha particles have more charge and alpha particle have more kinetic energy. That's why they have more ionization power. Third part says that isotope of neptunium produced by americium 241 is also radioactive. The decay of this isotope of neptunium produces an isotope of protactinium, which decays by beta emission. Beta particles are more penetrating than alpha particles. The half-life of neptunium is longer than 2 million years. Using this information, explain the advantage of long half-life for the use and safe disposal of household alarms. Firstly, we need to know what is half-life. Half-life is the time period in which the radiations emitted by any sample is reduced to half. So time taken for radiations to half is the half-life of an element. Now suppose that we have a sample in which we have nucleuses that are emitting radiations, and the radiation count per minute is very high because it's a new sample, and this sample has a short half life. That means it will emit radiations quickly and the count would be reduced to half very quickly. So that means the radiation emission of this sample is fast. On the other hand, the sample which has a long half-life means that the radiation emission of this sample is very slow, because it will take longer time for this sample to reduce its radiations to half. So long half-life means radiation emission is slow and it is safer and it is less hazardous. Question number 10 says the Milky Way is one of many billions of galaxies. Each galaxies contain many billions of stars. Stable stars transfer energy into space by emitting electromagnetic radiations from their surfaces. Describe what happens in the core of the star to release energy. Energy in stars is basically released by the process of nuclear fusion, in which two hydrogen nuclei fuse into each other and form helium nucleus. along with formation of neutrons and a large amount of energy. So, in stars, nuclear fusion occurs. Atoms of hydrogen fuse to each other, and helium, along with neutrons, and large amount of energy is released. B part says, on the Earth, light from distant galaxies is observed and analyzed by astronomers. This information is used to determine the speed at which galaxy is moving away from the Earth. Describe how observed light is different from the light that was emitted. For this, we need to know few concepts of Doppler effect. Doppler said that if Earth is at rest and the galaxy we are observing is also at rest, so the light emitted by the galaxy would have same wavelength when it approaches Earth. But if the Earth is at rest and the galaxy is approaching the Earth, that means it is moving towards the Earth, then light emitted by the galaxy would have wavelength smaller when it will reach the Earth. That means the wavelength of the light when it moves towards the Earth will reduce. Similarly, if Earth is at rest and the galaxy we are observing is moving away from the Earth, then the light emitted by that particular galaxy would have a longer wavelength when it reaches Earth. That means the shorter wavelength is converted into longer wavelength if it's moving away. That means the galaxy moving away, the wavelength of the light would increase and it will move towards a red color. And this process is also known as redshift. This is the answer to the question that if something is moving away from the Earth, the wavelength of the light when it reaches Earth would be longer than the previous, and also the color would change to red. So the answer to this question is wavelength of the light is longer than the wavelength of the light emitted, and the light is shifted towards red. And this process is also known as redshift. Second part says state the quantity that astronomer used to determine the speed at which galaxy is moving away. So the answer is same. The change in wavelength of light determine the speed of galaxy moving away from the Earth. The Hubble constant h naught is equals to 2.2 into 10 raised to power negative 18 per second. Calculate the distance from the Earth of galaxy that is moving away with the speed of 1.3 into 10 raised to power 7. So Hubble constant is equals to speed over distance. Distance is equals to speed over Hubble constant. And putting in the values 1.3 into 10 raised to power 7 divided by 2.2 into 10 raised to power negative 18 would give us the answer of 5.9 into 10 raised to power 24. Calculate an estimate for the age of universe and give your answer in years. Age of universe is equals to inverse of Hubble constant. So it would be 1 over 2.2 into 10 raised to power negative 18. And when you put all this into your calculator, you will get the answer of 0.45 into 10 raised to power 18. But if you convert it into years, you will divide it by 365 multiplied by 24 multiplied by 60 and multiplied by 60 again. So this is equals to 4.5 into 10 raised to power 17 years. If the video was helpful for you, please hit the like button and subscribe my channel and stay tuned for more informative videos.